Alright, hello everyone, this is Mr. Crozier. I'm going to give you some help with these triangles here. Again, we have two special triangles, 30, 60, 90. These are the degrees, 30, 60, 90. And a 45, 45, 90. Two special triangles, and don't worry, these are the only ones you need to know. And there are certain patterns here, and the pattern is from this short side over here. If you work your way out from the short side, you times this by 2 and you get to the hypotenuse. And if you take the short side and you times it by root 3, you get to here. So if you remember that pattern here, you'll do fine with this one. And on the 45, it's even a little bit easier. There's just two congruent angles, so we're going to take this x and times it by root 2. And we're going to take this x and leave it the same. So knowing those patterns, here we go. Problem. I have 6 problems here for you. First one, A, 30, 60, 90, and I always like to draw mine with the short side up here and 30 down there, because then it's real easy for me to just draw this pattern, and if this is 11, this is 22. Very simple. And if this is 11, then this is 11 times root 3. And that's it. And we could get a decimal for that. Let me see, I have a calculator right here. Let's see here. We could say that's 11 times the square root of 3. And it's about 19. So this is about 19.05. But we're not going to use decimals. We're going to use exact values. So we're going to use roots. We're not going to have a calculator to begin with. And we want an exact answer. So we want 11 times root 3, which is about 19. But we're not going to write down the 19. We're going to do that. Alright, down here again, same thing. Times 2. It's 3 times 2 times root 5. We multiply those and get 6. And we leave the root 5. Because again, we don't want to multiply that. If you had your calculator, you could. 6 times root 5. It's about 13. But we're not using decimals. Alright, and we multiply this one by root 3. So it's 3 root 5 times root 3. And here these go together, and I have 3, and that would be root 15. So this is 3 root 10, 6 root 5, 3 root 5. And again, there's decimals. We're not interested here. Alright, now working backwards here, well, if I times it by root 3 to go forwards, to go backwards, I'm going to divide by root 3. So I have 10 divided by root 3. We can't leave a radical down here, so we're going to simplify it by multiplying by root 3. And I have 10 roots of 3 over 3. So that's this measurement. I know that's a weird number and you want a decimal for that, but we're not using decimals. And we times this by 2, so it's 20 root 3 over 3. Alright, again, divide to go backwards, multiply to go forwards. If you remember this plan up here, you always get it. The 45 is a little bit easier. If this is 9, that's 9. And then if I swing this out here, 9 root 2. Down here, 10 root 2, or sorry, 2 root 10. Same thing there. And if I multiply this, 2 root 10 times root, sorry, that's going to be a 10, times root 2 is 2 roots of 20. However, this is our first case where we can simplify that, right? That is the same as root 4 times root 5, because 4 times 5 makes 20. So root 4 is really another 2. So I have a 2 and a 2, which is 4 roots of 5. Alright, and the last one, 14 here. Well, how do I go backwards? Well, forwards is going root 2, backwards is divide by root 2. So 14 divided by root 2. Again, we don't leave these down here, so we multiply it by root 2. 14 root 2 over 2. Well, hey, 14 divided by 2 is 7 roots of 2. And if that's 7 roots of 2, then this is 7 roots of 2. Alright, in every triangle we have figured out all of the missing sides without using Pythagorean theorem, right? We could have used a squared plus b squared equals c squared if we have two sides, but we are only given one. And when you're only given one, hopefully you have a special right triangle. Alright, this should set you up to get your homework done.